All right, computation with scientific notation. Sounds like a bit of a mouthful, but it's not too bad when you're multiplying and dividing. So you're just going to gather the like terms, really, because everything's being multiplied. So you've got this times this. So 7.3 times 2.4. That's going to give you 1752. 17.52 times 10. I've got the same base, different exponents. I just add them. 10 to the 11th. All right, no big deal. This is a wannabe. It wants to be scientific notation. It is not, because you have 2 digits up front, so we need to make an adjustment. 1752 times 10. Put my decimal there. I moved it 1 place value. So that means to maintain my value, I need, since this went 1 place value smaller, then my exponent has to get 1 exponent bigger. And there it is. That's for multiplying. Now, let's look at division. It's going to follow the same type of trend, which is pretty nice. So we have 4.62 times 10 to the 7th over 1.2 times 10 to the 4th. Okay, well, again, what we're going to do is we are going to go ahead and divide those two out. 4.62 divided by 1.2, you're going to get 3.85. 3.85. Now, we're going to deal with times 10, and dividing, same base, we just subtract the exponents, so it's 10 cubed. And is it in scientific notation? Yeah, this one actually is. I don't have to adjust it. So when you're multiplying and dividing, you just have to watch for those adjustments. All right, now, adding and subtracting, there will be adjustments. It's just the nature of the beast. So what we have here is 6.98 times 10 to the 5th power. And we're going to add it to 1.65 times 10 to the 7th. Now, if you look at this, you're thinking, oh, good, I'll just stack them and move on. No, you really can't do that, because this is to the 5th power. So that number in standard form would be 698 with 3 zeros. This one would be 165. So you can see how they're lined up differently. All right, so we have to make that adjustment in the scientific notation, because you're not going to want to do that when you have the much larger exponents. All right, so let's look at this. It doesn't matter which one you move, but you're going to take one of these exponents and make it match the other. Now, I'm going to keep the larger exponent, and I'm going to adjust the smaller one. So let me set up, and I'm going to have 1.65 times 10 to the 7th. And I've pushed it apart for a reason. So let's look here. I need this to be, this 5 to become a 7. So I'm going to add 2 to it. That means this decimal needs to move twice. So it's going to be 0.06. 0.0698 times 10 to the 7th. Now, you can see why I left that space. It's because I had all that after the decimal. Now, I can go ahead and put zeros there. They don't change the value, but they make it nicer to deal with things. So now I've got 8, 9, 11, 7, 1. 1.7198 times 10, my exponents match, so it just drops. Now, I'm going to check it again. Did my final answer land in scientific notation? Yeah, it actually did. So I'm good to go now. Now let's look at a subtraction one. It really is going to be the same type of thing, only instead of adding the two together, you're going to subtract. So, but we'll look at one. 3.64 times 10 to the 6th minus 2.18 times 10 to the 4th. Now, we're going to go ahead and adjust our smaller exponent to make them match because they'll land closer in scientific notation. So 3.64 times, I didn't leave my space, times 10 to the 6th minus something else times 10 to the 6th. Okay, so we're going to move this 1, 2. So it's going to be 0, 2, 1, 8. All right, and again, with these, you really want those zeros there, or truthfully, you're going to run it out in the calculator. 3.64 minus 0.0218. You will get 3.6182 times my exponents are matching. I'm just going to drop it. And there you go.